Okay, let's keep going. All right, so now we're going to do an example of the CLT for sums. So an unknown distribution has a mean of 90 and a standard deviation of 15. A sample size of 80 is drawn randomly from the population. Okay, so at first one, it wants me to find the probability that the sum of the 80 values or the total of the 80 values is more than 7,500. In part B, find the sum that is 1.5 standard deviations above the mean of the sums. Okay, have you noticed how many times I've said sum in that one slide? Okay, because that's telling me I need to look at my sums. I'm not dealing with my means here, I'm dealing with my sums. So let's keep going. Okay, first step, find that mean and that standard deviation. Okay, so I'm going to break down the problem. So it gave me the mean and it gave me a standard deviation and it gave me my sample size. All right, and then I've got to plug it into this nasty formula down here, but it's really not that bad. So let's go look at it. If it'll let me. Okay, so here we go. All right, I just plugged everything in here. And the first part right here is just basically my mean. So the mean is 80 times 90, which is 7,200. Okay, so that new mean is 7,200. We didn't have to do that with the other problems we did, but now we do. Okay, and then my new standard deviation is 134.164. Okay, how did I do that? The square root of 80 times 15 gives me that answer. That's all you have to do. Yeah, you have to break out the calculator, but it's really not that bad. Okay, so next up, let's go to Minitab. I'm going to go out of here for just fast. I'm going to do it. Okay, get a good graph. Okay, and then I'm going to go graph, going to probability distribution plot. I'm going to do view probability. Do it the exact same as I did before. Put in my new mean, put in my new standard deviation. And then I'm going to go here for the shaded area. Remember, it's going to be a right tail because it's more than, and I'm going to put my 7,500 here. And then I'm going to hit OK. And it gives me a graph. Oops, can you see it? I don't know if you can see it. Okay, so, but let me go look at the PowerPoint because I have it on there. So let's go see. All right, here's the PowerPoint. All right, it was a right tail, so that means the area is in red, and it gave me 0.01267. So for this unknown distribution, the probability that the sums of the 80 values is more than 7,500 is 0.01267. Okay. Again, I can use the central limit theorem because my sample size is at least 30. All right, so let's keep going. All right. Now remember, I'm going to use, it wanted me to find the sum that is 1.5 standard deviations above the mean. Remember normal distribution, that z-score could tell us where things were on the standard normal curve. Because remember, what the z-score does is it takes everyday values, compares them to the mean and the standard deviation, and then standardizes it so we can put it on the standard normal curve. Basically, what I'm doing is I'm wrangling that data, and I want it to be normalized so I can compare it with other things. So using that formula, let's see what I'm going to do. So I have this nasty formula here. And what I want to do is I'm going to solve for this right here. I'm going to highlight it so we can see it. I'm going to solve for that. So basically what I do is I changed the formula to make that easier. Basically, I put everything else on the other side while I did that. So if you don't want to have to remember the algebra to do that, just know this formula, okay? So to get that, I'm doing n times the mean that I was given, sample size times mean, plus the z. So let me put everything in here. I didn't do a very good job of doing that. So let me do this. We're going to go back and, because I don't like how I did this problem, and I don't think I did a good job of explaining it. Okay. So n, remember, was 80. The mean was 90. Oops. The z, remember, it wanted 1.5 standard deviations. This right here, this square root, this little n right here, is going to be 80. And this right here, remember, was going to be 15, okay? So if I put it all in my calculator, so 80 times 90 plus 1.5 times the square root of 80 times 15 gives me my answer, 7,401.2. Okay, so that's how I got my answer. And I think my answer is just a tiny bit off. So let's put it that way. So we're all consistent. Yeah, I might have done this with a different calculator before. Okay, that's how you get it. So the sum that is 1.5 standard deviations above the mean is 7,401.2. Hope this helps.